Okay, question one. Given that the vector PQ is negative 3, 7, and 4 times the vector PR is negative 2, 8, we want to find the vector R to Q. Now, I think the best way to do this is really just to visualize what's going on, right? Because vectors are basically visual things. So I'm going to imagine here that I've got P, Q, and R as these 3 points. What is it I want to find? I want to find the vector that goes from R to Q, right? So I'm trying to find this vector here. Well, how could I go from R to Q? Well, what I could do is I could go from R to P, and then I could go from P to Q, isn't it, right? So that would work. So let's try to write out that. So I'm going to say that the vector R to Q is the same thing as going from R to P and then going from P to Q. Okay. All right then. Well, what's the vector R to P? Well, we don't have R to P in this information here, but we do have something about P to R. So what's the relationship between RP and PR? Well, RP is equal to negative PR. Now, why is that? Well, because you're going in the opposite direction, right? So if I was to think about this, going from R to P is like doing P to R, but in reverse, right? So RP is minus PR. I'm going backwards. Okay, and we've got PQ. That's given in the information, so that's quite good. So we can write that there. So that's PQ. So now let's try to fill in. Well, we don't have PR exactly. We have 4 lots of PR. So I know that PR is going to be a quarter of this thing here. So I'm going to now write negative a quarter of the vector negative 2, 8. And then I'm going to include the vector PQ, which is the vector negative 3, 7. And so now hopefully everything should be quite simple, right? So I'm just going to expand the first vector. So I've got negative a quarter times by negative 2, which is a half. I've got negative a quarter times by 8, which is going to be negative 2. And then I'm going to add on the vector negative 3, 7. Okay, so now it's just simple vector addition, right? So I've got a half plus negative 3, so it's going to be negative 2.5 or negative 5 upon 2. And then I've got negative 2 plus 7, which is positive 5. Right, so therefore the vector R to Q should be equal to negative 5 to 5. Okay, so part B of this vectors question, we've got the vectors A, B, and C are such that A is alpha I plus 6j, B is 4I plus beta j, C is 2 alpha plus 5 beta I plus 20j, where alpha and beta are scalars, and given that C is equal to 3A minus 2B, find the values of alpha and beta. Now, I think personally that it's much easier to deal with vectors if you write them in column notation. Now, my background is that I did a degree in engineering, and I very quickly learned that when we're dealing with vectors, it's just so much easier to use the column notation. It makes your operations a lot easier to manipulate, to understand. So I'm going to do that, even though you don't have to. I think it will help you. So I'm going to write that out like this. And what are we told? We are told that C is equal to 3A minus 2B. So I'm going to write that out now in full. Here we've got C, so we've got 2 alpha plus 5 beta, 20, is equal to 3 lots of A, so 3 lots of the vector alpha 6, minus 2 lots of the vector 4 beta. Okay, and so let's just expand the right-hand side of that, right? So the first thing I can do is I can multiply the scalar 3 by this vector here, which is going to give me 3 alpha 18. And I can do the same thing with the 2, so that's going to give me 8 and 2 beta. And then what I've got is I've got simple vector addition, or rather subtraction in this case, such that I've got 3 alpha minus 8 and 18 minus 2 beta. And of course, that's got to be the same thing as 2 alpha plus 5 beta, 20. Now, if we've got two vectors which are equal, what does that mean? It means that the I components, right, the horizontal components, this thing and this thing must be the same. And also the j components, the vertical components, must also be the same. So in other words, we know that 2 alpha plus 5 beta is equal to 3 alpha minus 8. And we know that 20 is equal to 18 minus 2 beta. So essentially we've got simultaneous equations here, but it's going to be easier for us to deal with the second of these first because we can straight away find out what beta is. So I'm going to go to here, and so I'm going to write 20 is equal to 18 minus 2 beta. So if I rearrange that, 2 beta is equal to negative 2, and that means that beta is equal to negative 1, right? So that's fairly straightforward. Then if I take the first row, I get that 2 alpha plus 5 beta is equal to 3 alpha minus 8. And of course, we know that beta is negative 1, so this is 2 alpha minus 5 is equal to 3 alpha minus 8. I will bring the 2 alpha to the right-hand side, so that's alpha, and I add 8 to both sides, that's 3. So alpha is equal to 3. Okay, and that should be our answer. Okay, then question 2, we want to solve the inequality 3 minus x times 5x plus 8 is greater than or equal to 9 minus 3x. So the first thing I'm going to do is I am going to expand the left-hand side. So I've got 15x plus 24 minus 5x squared minus 8x. And that must be greater than or equal to 9 minus 3x. And so let's rearrange this. I think I'll bring everything to the right. So I'll bring the 5x squared to the right-hand side, so I get 5x squared there. What are the x terms that I have? Well, I've got 15x here, minus 8x is 7x. And I subtract the 7x from the left and bring it to the right, which will give me minus 10x. And then here I've got 24, and I subtract that from 9, and that's going to give me negative 15. And I think I can divide everything through by 5. That will make things a bit easier. So I get x squared minus 2x minus 3. Now, what are we trying to do here? We are trying to find when the quadratic x squared minus 2x minus 3 is less than 0. I think the best way to really understand this is we want to draw the quadratic out. We want to sketch it out and see where the quadratic is less than 0. In other words, where it is below the x-axis. So think, how can I sketch this out? Well, it'd be a good idea to factorize so I know what the roots are. So I get x minus 3 and x plus 1 there. So that means that if I was to draw this out, the graph should go through the point negative 1 and positive 3. Right? So here's negative 1 and here's positive 3. So my quadratic is going to look something like this. Right? So like that. Okay. So this guy, that's the quadratic, right? Y is equal to x squared minus 2x minus 3. And you've got to ask yourself the question, well, where is that quadratic less than 0? Where is it less than 0? Well, it's less than 0 everywhere here, right? Because that's where the y coordinate is less than 0. We're below the x-axis. So we are interested in this part of the curve. And what x values do we have to get that part of the curve? Well, the x values are going to be everything from negative 1 all the way up to positive 3. So the solution is going to be that x must be greater than or equal to negative 1 and less than or equal to positive 3. Okay, so can I encourage you, if you're solving these inequalities, use a sketch because it will help you to actually understand how to get the right solution. Right, question 3, which is a circles question. The point A has got coordinates 3, negative 1. A circle has got this equation here. We want to show that the point A lies on the circumference of the circle. In other words, that means that this point satisfies the equation of this circle. So that should be fairly easy to show. We just substitute the point into the equation and see that we get 5. So let's do that. X is 3, so we get 3 minus 4 squared. Plus y, which is negative 1 plus 3 squared. Well, let's try to solve that. So 3 minus 4 is negative 1, so we've got negative 1 squared. And negative 1 plus 3 is 2, so we've got 2 squared. Negative 1 squared is 1, 2 squared is 4, and that's equal to 5. Right? So we've satisfied the equation, so we know that 3 negative 1 is on the circle. B, given that AB is the diameter of the circle, find the coordinates of B. Now, I think in order to do this, really, we need to actually understand this what the circle looks like. And hopefully you'll realize by now that if we've got an equation of a circle which is of the form x minus a squared plus y minus b squared is equal to r squared, then this is a circle with center on the coordinates a comma b, and which has a radius that's equal to r. So if we were to look at our circle here, right, we know that the center of the circle has got to be at the coordinates 4, -3, right, because it's like y minus minus 3. And the radius of the circle is the square root of 5. So we've got a circle, right, where the center is the coordinate 4, -3, and which has a radius which is equal to root 5. So why don't we just try to kind of draw out what this is actually going to be. I think it's always helpful to sort of visualize what's going on. So here, let's say we've got a circle. Ooh, okay, it's good enough. And we're saying that the center of that circle is 4, -3. And we know that we've got a point on that circle, which is A, which is the coordinate 3, -1, right? So if I was to go here, let's say this is A, which is 3, -1. We've kind of got all the information which we need so far. Now, what are we being told? We're told that B is also on the circle such that AB is the diameter. Well, if that's the case, I can draw a line, can't I, that goes from A through the center, and it's going to go to there, which will be the coordinate B. So this guy here is B. So then there are two ways that we can think about this, right? We can either say that this coordinate here is going to be the midpoint of A and B, and we can use the midpoint formula. Or we could try to think about it this way. So I'll try to think about it this particular way with you, which is how far do we have to go down from A to the center, and how far do we have to go across? Well, if we think about it, going down, we go from a y coordinate of -1 to a y coordinate of -3, right? So we're going down 2 steps. And how much do we have to go across? Well, we go from an x coordinate 3 to an x coordinate 4, and that's going across by 1, right? So that's 1 there. Well, if that's the case, right, then the step that we have to go from the center to the point B on the opposite side must be the same, right? I've got to go down 2 and I've got to go across 1. So I'm going to go down 2 and I'm going to go across 1. So if I go down 2, right, from -3, I'm going to go down to the y coordinate -5. And if I go across 1, I'm going to go from 4 plus 1 to 5. Okay, so that's thinking about it kind of visually that way. But of course, we could do it with the midpoint as well, right? And we can kind of verify. I'm going to take the midpoint of A and B. So if I've got 3 plus 5 is 8, divided by 2 gives me 4. And -1 plus -5 is -6, divided by 2 gives me -3. Okay? Well, okay then, we're on part C, so we want to find the equation of the tangent to the circle at A. So let's go back to our diagram. We kind of need this. We want the tangent to the circle at A, and that's going to be this line here, right? So let me draw it. I'll draw it in red. Why not? So that's going to be that line there. Okay. Now, the really key thing for you to know, the core fact that you need to remember, is that the tangent to the circle is perpendicular to the radius line, right? So this is perpendicular to that. Okay. So then, if I want to find the equation of the line, what do I need? Well, I always need two things. I need the coordinate point, which I've got, it's 3, -1, and I need the gradient of the line, right? So I need to find the gradient of this red line. How am I going to do that? Well, first I can find the gradient of this green line, the radius line, and then I can do the negative reciprocal to find the gradient perpendicular to that. Okay, so what I'm going to do is I'll find the gradient. Let's say I find the gradient from A to the center, call it AC. And the gradient is y2 minus y1, so -3 minus -1. So -3 minus -1 over x2 minus x1, so 4 minus 3. So what's -3 minus -1? Well, it's -3 plus 1, which is -2. And 4 minus 3 is 1. So this gradient is just equal to -2, right? And so if that's the gradient of AC, what's going to be the gradient that's perpendicular to that? Well, it's the negative reciprocal, so it's -1 divided by -2, which is just +1/2, right? So we've now got the gradient of that red tangent line there. So how then can I find the equation of the line? Well, we can use our formula, right? Y minus y1 is equal to mx minus x1, where m is the gradient of our line and x1, y1 is the coordinate point. So if I just substitute in, I've got y minus 1 is equal to m, which is a half, x minus 3, okay, which is y plus 1 is equal to a half x minus 3 upon 2. And I could subtract 1 from both sides if I wanted to. Y is equal to a half x minus 5 upon 2. And that would be our answer. Okay, then question 4. Solve the equation x to the power of 1 upon 3 minus x to the power of 1 upon 6 is equal to 2. So I think I'll just rewrite that for you. So x to the power of 1 upon 3 minus x to the power of 1 upon 6 is equal to 2. Now, usually the trick with these kind of indices equations, exponential equations rather, is they're hidden quadratics. And I think in order to see that in this case, you need to rewrite this x to the power of a third here and write it as x to the power of 2/6. And then it becomes a little bit more clear. Okay, so it's a slightly harder one than usual, I think, but once you've done that, hopefully it's relatively clear, because I can now rewrite this as x to the power of 1 upon 6 to the power of 2 minus x to the power of 1 upon 6 is equal to 2. And therefore, I can use a substitution. I can say let u equal x to the power of 1 upon 6. And so we've got u squared minus u is equal to 2. Or rather, u squared minus u minus 2 is equal to 0. And then we can factorize this. So we get u minus 2, bracket u plus 1, is equal to 0. And that gives us that u is equal either to -1 or u is equal to positive 2. And so x to the power of a sixth is equal to -1, or x to the power of a sixth is equal to positive 2. Now, one of the things you need to know is that this guy has to be rejected, right? Because it's not possible for x to the power of 1 upon 6 to be equal to -1 if we're defining it in terms of like functions. So hopefully you will remember that we cannot have a one-to-many function, right? So for example, if I've got the graph of the square root of x, right? So I've got the positive square root and I got the negative square root like that, right? So like y is equal to root x, then this is going to be a one-to-many mapping, right? Because let's say I've got 4. 4's got a possible solution of 2 and also -2, right? We can't have that. So instead what we do is we've only take the positive values, which means the range of this, right? The y values are only positive as well, right? So for example, just as a in this case, let's say we had x to the power of a half was equal to -1 as a solution, right? Then we'd say this was, well, hang on. When we say x to the power of a half, what we mean is actually like just this curve here, these values. So the x values are only positive and the y values are only positive. So it can't be equal to -1, right? And that's not true, for example, if we had like the cube root of x, x to the power of a third, because in that case, the graph would look more like this, right? The cube root of x would be this, like that. And because that's not a one-to-many mapping, that's still just a one-to-one mapping, then we could have negative values, right? But for the case when the root is an even number root, right? So it's the square root or the fourth root or the sixth root, then we face this problem of a one-to-many mapping, which limits the function, so you can only have positive values. All right, so that's just an explanation for that, because I'm guessing that that's going to confuse some of you all. So we end up with x to the power of a sixth is equal to 2. So x is going to be equal to 2 to the power of 6, and 2 to the power of 6 is going to be 64. Okay, so that is the answer. Okay, part B, we want to solve the simultaneous equations that we've got here. Well, I think what you want to do is you want to start with the first one. Okay, so we've got log x plus 2y is equal to 0. So how can I rewrite that? Well, log is log base 10 So we've got log base 10, x plus 2y is equal to 0. So if we rearrange that to exponential form, then we've got x plus 2y is equal to 10 to the power of 0, and anything to the power of 0 is 1. So we've got x plus 2y is equal to 1. So we've got that first thing there. And I think that means we can substitute it into the second equation, right? So we'll rearrange this. That's x is equal to 1 minus 2y. And we'll substitute it in to the quadratic. So we got 1 minus 2y all squared plus 4 times 1 minus 2y times by y plus y is equal to 1. So if now we expand all this, so that will give us 1 minus 4y plus 4y squared plus 4y minus 8y squared plus y is equal to 1. So 4y squared minus 8y squared is minus 4y squared. We got minus 4y plus 4y is 0 plus y is plus 1y. And then we have got 1. And then we can subtract 1 and that will give us 0. So then if I factorize out, let's factorize out negative y, I guess. If I factorize out negative y, that becomes 4y minus 1. And so therefore we've got two solutions. We've got y is equal to 0 and we've got y is equal to a quarter. And of course we know that x is 1 minus 2y. So x is equal to 1 minus 2y. And so therefore when y is equal to 0, right, x is going to equal to 1 minus 0, which is 1. And when y is equal to a quarter, x is going to equal to 1 minus 2 times by a quarter. So 2 times a quarter is a half, and 1 minus a half is just going to be a half. So I end up with two solutions. The first is 1, 0, and the second solution is going to be a half, a quarter. Okay? And that should be it. Okay, so we've got question 5 here. We want to solve the equation 5 times the modulus of 2x minus 1 plus 8 is equal to 23. I think it's a good idea just to review what the modulus actually means. So if we've got, let's say, the modulus of 3, that's equal to 3. Whereas if we've got the modulus of negative 4, then that's equal to 4. So what's actually happening here? Well, if the number inside the modulus is positive, there's no change. The number remains as it is. But if the number inside the modulus is negative, then the modulus turns it into a positive. Now, how can we think about that actually working? We could think about that and say that when the number on the inside is negative, the modulus takes it and multiplies it by a negative, right? So we get negative 4, which is equal to positive 4, right? So we could say that if the number inside the modulus is positive, there's no change. But if the number inside the modulus is negative, the modulus turns it into a positive. And how does it do that? It multiplies it by negative 1. Okay, so that's kind of a way that we can think about it. And it's a way we're going to use as we do this problem. So first thing, what I'm going to do is I'm going to rearrange this equation. I'm going to subtract 8 from both sides. So I've got 5 times by the modulus of 2x minus 1 is equal to 15. And I'm going to divide both sides by 5. So I got the modulus of 2x minus 1 is equal to 3. And now I've got two options, right? The first option is if 2x minus 1 is positive, right? So if that's positive, then there's going to be no change. 2x minus 1 will be equal to 3, right? Because the modulus isn't going to do anything. So we get 2x is equal to 4 and x is equal to 2. But on the other hand, right, if 2x minus 1 is a negative number, then what's going to happen? Well, the modulus is going to turn it into a positive. And how will it do that? Well, it will take the 2x minus 1 and it will multiply it by negative 1. So we end up with this, right? So I could say this is now 2x minus 1 is equal to negative 3. So 2x is equal to negative 2 and x is equal to negative 1. Okay, then 5b, on the axes we want to sketch the graph of 5 sine x minus 2. Now with these cases I think it's always best just to review how we sketch any trigonometric graph. So if we've got y is equal to a sine bx plus c, we want to understand what the letters a, b and c stand for. Now you've probably seen me do this a couple of times if you see my other videos. Let's start with a. Actually, let's go with c. C is the shift in the y direction. And I think it's better to think of that as the horizontal center line, right? So it's the line that the rest of the graph kind of oscillates around. Next, let's have a look at B. What does B mean? Now, a lot of my students say to me that it is the period, but that's wrong. B is the number of waves in 360 degrees, if you're using degrees, or 2 pi radians if you're using radians. Right now, to give it its technical name, it's called the circular frequency, right? It's the number of waves you get in 360 or 2 pi. So let's now think about it. If B is 2, what that means is that there are 2 waves in 360 degrees. So if you ask yourself the question, well, then what's the period of the wave? In other words, how long is one wave? Well, it will be 360 divided by 2, right? Because there are 2 waves in 360, so each wave has got to be 180. In the same way, if B is 3, that means there are 3 waves in 360, and so the period is going to be 360 divided by 3, 120. So the thing you really need to understand is that B is not the period, but you can use it to find out the period, right? Because the period will be 360 degrees divided by whatever value of B you've got. Or, if you're using radians, 2 pi divided by B. Okay, so I think that's usually the place where students are confused, and I think that that's the thing you actually need to remember. You need to get it out of your head. B is not the period. This guy's not the period. Okay, lastly, A is the amplitude. Okay, and what do we mean by the amplitude? Well, we mean the distance from that center line up to the peak or down to the trough. So with that in mind, let's just go back to here, right? So what do we got? We have got that C is -2. What does that mean? It means that the whole graph is shifted down by 2, and so it's going to be centered along this horizontal line of y is equal to -2. Okay, so we know that the graph is centered along that line there. What about the amplitude? The amplitude is 5, right? So that means that from the center line up will be 5, and from the center line down will be 5. Well, if I start at -2 and I go up by 5, I'm going to go to +3. And if I start at -2 and I go down by 5, I'm going to be at -7. So I know that my graph is going to oscillate around -2 as the center, go up to 3 and down to -7. So my graph has got to be between these lines. Okay, lastly, what's my B value? Well, you can kind of think of it and say that this is like 1x, right? So B is 1, right? So B is equal to 1. And if that's the case, what's the period going to be? Well, the period will be 360 divided by 1. Or, yeah, we're using degrees. 360 divided by 1, which is just 360. So one wave is 360 degrees. Okay, then. Lastly, how do we actually sketch? Now, when you sketch out a sine or a cosine graph, you want to think of it as it's composed of 4 equal parts, right? So if I was to sketch this like that, kind of, oh dear, it's not so good. But it's kind of got 4 parts. It's got a part where you start from the center and go up to the peak. And then you go from the peak back to the center. Then from the center down to the trough. And then from the trough back to the center, right? So you kind of got 4 equal parts. 1, 2, 3, 4. And if you think of it like that, then your graph is not going to be this weird kind of lopsided thing like that, you know, like a lot of students give, or kind of like that. Okay, it'll be nice and smooth and even. So what have I got to do? First part, I've got to realize that I've got 360 degrees. I divide that into 4 equal parts. That will be 90 degrees for each part, right? So 90 degrees for each part. Just indicate that on, like 90 there and 270 there. Okay, so what am I going to do? Well, in the first quarter, I'm going to start at the center and I'm going to go up to the peak. So the peak is there. And then in the second quarter, I'm going to go from the peak back to the center. And then the third quarter, I'm going to go from the center down to the trough. And then the fourth, I'm going to go from the trough back up to the center. Now notice when I say center here, I'm not referring to the x-axis, right? Because the whole graph has shifted down. So the center is now along the line y is equal to -2. So if I was now to join up these dots, I'm going to get a curve that looks something like this. Sorry about that. My sketches are not great on a tablet. Oh dear. Okay, just bear with me. And so that would be my graph. Okay. Now you need to kind of make sure that you've got a sort of smoothish curve. So I'm trying to do it with a tablet. Okay, like that. You can't have it as a sawtooth like that. That's wrong. And it needs to look kind of smooth. Okay. All right. Now I know I spent a bit of time on that, but I hope it's helpful to you in actually practically sketching it. Common mistakes are that students do the center line here, right? And so they kind of get a graph that's like that. Yeah. Don't do that. Remember the center is along, in this case, the line y is equal to -2. Okay, I hope that's helpful. Okay, so we're in question 6. A curve has got this particular equation here. We want to show that dy dx can be written like this, where a is a positive integer to be found. Okay, so this is a little bit of a tricky differentiation to do. Now, there are a couple of different ways that you can approach this. You could think of it as a chain rule, where you've got kind of this big fraction function inside of the function of x to the power of 4. Or what you could do is you could kind of split it up straight away, right? This is x squared minus 1 to the power of 4 over x squared plus 1 to the power of 4 and do a quotient rule. And I think probably on balance, that's what I would prefer to do. So that's what I'm going to do here. So I'm going to rewrite this as x squared plus 1, or sorry, x squared minus 1, beg your pardon, to the power of 4 over x squared plus 1 to the power of 4. And so because we've got one function divided by another function, we need to use the quotient rule. And if you need a reminder of the quotient rule, right, quotient rule is this. If you've got a function y is equal to u divided by v, right, where u and v are both functions of x, then dy dx is equal to v times by du dx minus u times by dv dx all over v squared. Right, so in this particular case, right, my u is this, the thing on top, and my v is this, the thing on the bottom. So I think what I'll do is I will differentiate both of these guys separately. So I've got u is x squared minus 1 to the power of 4, and my v is x squared plus 1 to the power of 4, and I'm going to differentiate both of these. So if I differentiate u, I've got to use the chain rule. Chain rule is when I've got one function, in this case x squared minus 1, inside of another function, which is kind of x to the power of 4, right? The big bracket to the power of 4. So if I differentiate that, I differentiate the function on the outside first. So I get 4 bracket to the power of 3. And then what I've got to do is I've got to differentiate the function on the inside, which is x squared minus 1. So if I differentiate that, I get 2x, and I multiply through by that 2x. Okay, and I'm going to do the same thing with v. So if I differentiate v, again, I've got a chain rule, right? Because the function x squared plus 1 is inside of the function x to the 4. So I differentiate that big bracket first, the function on the outside. So 4 bracket to the power of 3. And then I take that x squared plus 1, which is the function on the inside. I differentiate it, I get 2x, and I multiply through by 2x. So now hopefully I can substitute everything into my formula for the quotient rule. So y prime is equal to v, which is x squared plus 1 to the power of 4 times by du. Well, if I simplify that, I've got 8x times by x squared minus 1 to the power of 3 minus u, which is x squared minus 1 to the power of 4 times by dv, which is 8x times by x squared plus 1 to the power of 3. And of course, this is all divided through by v squared. And that will be x squared plus 1 to the power of 4. And I've got to square it like that. Okay, so we've already done most of the work. So now essentially what we're going to be doing is we're going to be simplifying. Now, How can I simplify? Well, I think what we really need to do is we need to factorize the numerator. So what are the common factors? Well, we've got x squared plus 1 and x squared plus 1 here, right? So we can factorize out x squared plus 1 to the power of 3. What also can we factorize out? Well, we've got this thing. We've got 8x, right? So that's easy enough. We can factorize out the 8x. And lastly, we've got x squared minus 1 there and there. And so because we've got x squared minus 1 to the power of 3 and x squared minus 1 to the power of 4, I can factorize out to the power of 3. Okay, so that's what I'm going to do next. So let's factorize out 8x times by x squared plus 1 to the power of 3 times by x squared minus 1 to the power of 3. So if I do that, then for this whole term here, right, once I factorize out 8x and once I factorize out x squared minus 1 to the power of 3, I'm just left with x squared plus 1, right, because I've already factorized out to the power of 3. So I've just got one of those terms left. So that's x squared plus 1. And then if I take this whole term here, right, I factorize out 8x, I factorize out x squared plus 1 to the power of 3. And if I factorize out x squared minus 1 to the power of 3, I've got one of those terms left there. So I've just got the x squared minus 1 to the power of 3 left over. All right, then. So what else? Well, on the denominator, I've got x squared plus 1 to the power of 4 to the power of 2, which is x squared plus 1 to the power of 8. Okay, so how can we simplify this further? Well, let's have a look at this x squared plus 1 term again, right? So let me kind of highlight that in green. We've got x squared plus 1 to the power of 3 and x squared plus 1 to the power of 8. Well, I can cancel off, can't I? I can divide top and bottom by the power of 3. So that is going to go. And this guy here, I subtract 3 and I'm left with 5. So that's simplified. What about inside this big bracket here? Well, I've got x squared minus x squared. So that's going to go. That's gone, gone, and gone. And I've got 1 minus minus 1, and 1 minus minus 1 is 2. So the thing here left is just 2. So if I multiply through by the 8, then what I'm going to end up with is 16x bracket x squared minus 1 to the power of 3 divided by x squared plus 1 to the power of 5, which I think is the form that we're asked to provide. Yep, that's right. And in this case, the a is going to be equal to 16. Right then, part B, we want to show that the curve has stationary points where x is -1, x is 0, and x is 1. Well, what is a stationary point? A stationary point is when the gradient is 0, so it's when y prime is equal to 0. Well, if we just go back, we learned that y prime is equal to this thing, so we set that equal to 0. And of course, if we do that, then it's only the numerator there that matters. So let me just copy that out. So 0 is equal to 16x bracket x squared minus 1 to the power of 3, I think it was, divided by x squared plus 1 to the power of 5. And of course, if you're a little bit confused what I just said about the numerator, just imagine if I multiply both sides by the denominator, right? If I multiply both sides by x squared plus 1 to the power of 5, then on the right-hand side, I'm just left with the numerator, but on the left-hand side, I've multiplied by 0. And of course, if I multiply anything by 0, I get 0. So what I'm left with is this, right? Just the numerator. I'm sorry if that seems a bit unnecessary to explain to some of you, but for a lot of students, actually, they are confused by that. And so what have I now got here? Well, I've essentially got two things multiplied together, right? I've got 16x times by this term here. And I know that when I multiply them, I'm going to get 0. So how's that possible? Well, either one of these things is 0, right? Either the 16x is 0, or the other thing is 0, right? The x squared minus 1 to the power of 3, right? Because if you think about it, right? If I've got 7 and I times it by 0, I get 0. And if I've got 0 and I times it by 5, I get 0. right? So under what circumstances, if I multiply two numbers together and I get 0, what's happened? Well, one of those numbers must have been 0. So that's the logic that we're applying here, right? If we multiply these things together and we get 0, it either means that this thing is 0 or that thing is 0, okay? So 16x is equal to 0, which means that x is equal to 0. Or alternatively, the x squared minus 1 to the power of 3 is equal to 0, which means that x squared minus 1 is equal to 0, which means that x squared is equal to 1. And of course, if I then square root that, I get that x is equal to plus 1 or negative 1. Okay, so I get the three solutions there. All right then, part 2, use the first derivative test to determine which two stationary points have the same nature and state whether they are maximum or minimum points. Okay, so what's this first derivative test? Because we haven't really seen that before, or not that I recall, on an exam. We usually determine the nature of a stationary point by taking the second derivative. So what's going on? Well, I think it's just best to consider what's happening with the actual curve itself. So here we've got a minimum or a local minimum, and here we've got a maximum, right, or a local maximum. So we've got a minimum here, it's a minimum, and this guy's a maximum. Now, let's just consider the gradients on either side of the minimum and maximum, right? So if I'm coming here on the left-hand side of the minimum, then my gradient, dy dx, has got to be negative, right? It's got to be a negative number. Whereas on the other side of the minimum, right, on the right-hand side, the gradient has got to be positive, okay? And similarly, if I was to think about the maximum, right, on the left-hand side of the maximum, my gradient, dy dx, has got to be positive. And on the other side, my gradient has got to be negative. Okay, so what can I do? If I know that I've got a minimum, for example, at x is equal to 0, right, so that was the case in the previous example, and I want to determine whether it's a minimum or a maximum point, what could I do? I could look to the left-hand side and the right-hand side and see what the gradients are, right? Is it going to go from negative to positive, in which case it's a minimum, or is it going to go from positive to negative, in which case it's going to be a maximum? So let's try to do that. We've got, what is our dy dx again? Our dy dx was 16x bracket x squared minus 1 to the power of 3 over whatever it was, x squared plus 1 to the power of 5, I think. And we have got stationary points at which values again? 0, -1, and +1. Okay, so let's kind of just imagine that we've got a number line, I guess. That might be the best way of thinking about it. Here's our number line, right? So -1, 0, +1, okay? And what we want to kind of figure out is, you know, what's the gradient here? What's the gradient here? What's the gradient here? What's the gradient here? Because we can see whether or not the gradient goes from positive, negative, or negative to positive. So I don't know, we could try, for example, x is equal to -2. So we've got a value that is to the left of -1, our first stationary point. And if we do that, then we're going to get y prime is equal to -32. We're going to get 4 minus 1, which is 3 cubed, over -2 squared is 4, plus 1 is 5, 5 to the power of 5. Now, this is a non-calculator paper, right? But we actually don't care about computing the value of this, right? That's irrelevant. All we're interested in is whether it's positive or negative. Is it positive or negative? Well, this is negative, isn't it? So what do we know? We know that the gradient over on this side is a negative gradient, okay? And similarly, we can do this with a value that's now between -1 and 0. So I don't know, let's take a half, right? So, or -1/2, beg your pardon. So x is equal to -1/2. And that means that y prime is equal to, so we've got 16 times by -1/2, that's -8. And then we've got -1/2 all squared, which is positive a quarter, minus 1 to the power of 3 over, so negative a half squared, which is again positive a quarter plus 1. So we've got a quarter plus 1 to the power of 5. Now, this is going to be a slightly different example, right? Why is that? We've got a quarter minus 1, so that's going to be minus 3/4. That's a negative number. And a negative number cubed is negative again. And then a negative number times by this negative 8 is going to be a positive number. And this number on the bottom is positive. So we've got negative divided by a positive. We've got a positive divided by a positive, which will be positives, right? So again, we don't actually have to calculate the value. We just need to know that this guy is positive. Okay, so here, between negative 1 and 0, we've got a positive. So what does that mean? It means that as we go from the left of negative 1 to the right of it, we've gone from a negative gradient to a positive gradient. Well, if we go from a negative gradient to a positive gradient, then the situation that we've got is this one here, right? Negative to positive, that's a minimum. Okay, so this guy here is a minimum. Okay, all right, well, let's try going to the right-hand side of 0, right? So we go to a half, so x is a half. So x is equal to a half. So y prime, okay, so we got a half times by 32, half times by 16, beg your pardon, which is positive 8. We've got a half squared, which is going to be a quarter, minus 1 to the power of 3, and a half squared, which is a quarter, plus 1 to the power of 5. Now, again, what's happening here? A quarter minus 1 is negative 3/4. Cubed is going to be a negative number. Times by 8 is going to be a negative number, and this is positive, right? So negative divided by a positive is a negative. So this guy is a negative number, right? So what have we just discovered? We here, right, as we go across x is equal to 0, we go from a situation where the gradient is positive to where the gradient is negative. And if we go from a place where the gradient is positive to negative, then we must have had a maximum. Okay, so this guy's a maximum. All right, jolly good. Okay, then, so now let's try the last one. Let's try x is equal to positive 2. So x is equal to positive 2. So y prime will be equal to, was it 16 times by 2? Which would be positive 32. 2 squared is 4, minus 1 is 3, 3 cubed, over 2 squared plus 1 is 5, isn't it? And then 5 to the power of 5. That should be that. And of course, everything there is positive. So the gradient there is positive. And so we got a positive here. So what's happened as we've gone across x is equal to 1? We've gone from where the gradient is negative to where the gradient is positive. And so again, we've got this situation here, right? Negative to positive, which means that this guy is a minimum. Okay, so we have got a minimum at x is equal to 1, a maximum at x is equal to 0, and a minimum at x is equal to positive 1, right? So minimum, maximum, minimum. So what are we asked to show? To determine which two station points have the same nature. Well, that's negative 1 and positive 1, right? And state whether they are maximum or minimum points. So they're minimum points. So the concluding statement will be something like both x equals 1 and x equals negative 1 have same nature, which is a minimum. Okay, so that's, you probably want to write something like that at the end. I'm just going to very quickly check the mark scheme, see if they do that. Yeah, conclusion, x equals 1 and x equals negative 1 are minimum points. Okay, all right, so I realize that's quite long. I know that's a bit convoluted, and you probably haven't seen it before on other exams, I don't think, but actually it's relatively straightforward. And if you just remind yourself that you don't care about the numerical value, all you care about is whether it's positive or negative, then this is definitely doable without a calculator, as long as you're, just thinking it through nice and clearly. All right, question 7. find the x-coordinates of the points where the curve blah blah cuts the x-axis. Now, I think probably many students, when they see this for the first time, they're going to be quite flummoxed, because this is not similar, as far as I'm aware, to a question in the past. And, you know, when questions are not similar, we tend to get a little bit scared and intimidated by them. But let's just take a step back for a second. What does it mean when we cut the x-axis? Well, we have an x-axis intercept, so x-intercepts are where y is equal to 0. Right now, just for the sake of those of you who it's never been explained to you why that is the case, right? I'll just draw an axis very quickly and just try to explain it to you right now. Okay, and like that. Okay, I want you to imagine what the coordinates are for each of these, right? So the coordinate of this is 1, 0, 2, 0, 3, 0, 4, 0, right? And negative 1, 0, negative 2, 0, negative 3, 0. In other words, on the x-axis, the y-coordinate is always 0. And similarly, if we take the y-axis, right, what's this coordinate? 0, 1. This one is 0, 2. This one's 0, 3. This one's 0, 4. 0, negative 1. 0, negative 2. So what do you know about the y-axis? The x-coordinate is always 0. So in other words, if we're trying to find, when we cut the x-axis, what we're trying to find is the x-coordinate when the y-coordinate is 0. And when we're trying to find the y-axis intercept, we're trying to find the y-coordinate when the x-coordinate is 0. Okay, so that's an explanation for those of you who've never had it explained to you. Okay, so we're trying to find where y is 0. So what's going to happen then? Well, we're going to get 0 is equal to 2x minus 9 times by x squared plus 5 plus 42. Well, I think the best way to handle this is just to expand it, right? So we're going to expand all this thing. So we've got 2x times x squared, which is 2x cubed, 2x times by 5, which is 10x, minus 9 times x squared, which is minus 9x squared, minus 9 times 5, which is minus 45, plus 42. And then if we simplify this, 2x cubed minus 9x squared plus 10x, and then minus 45 plus 42 is minus 3. Well, then what are we actually being asked to do in this question? Now it's a lot simpler, isn't it? We are being asked to solve this cubic equation, to find the roots of the cubic. And how do we find the roots of any cubic? Well, hopefully you know that we look at this last element, right, the last number, the constant term, and we say to ourselves that the factors of this number are very likely to be the roots of the cubic polynomial, right? So what are the factors of 3, or negative 3? It's plus and minus 1 and plus and minus 3, right? So we've got to deal with the positives and the negatives. And so these are the possible roots, right? So we don't know if they are, and they may not be, but it's very, very likely. So we're going to try those numbers. So what I'm going to do is I am going to substitute in x equals 1 to start with and see if that gives me a root. So let's try that. I'm going to get 2 times by 1 cubed minus 9 times by 1 squared plus 10 times by 1 minus 3. Well, what does that give us? We've got 2 minus 9, which is minus 7, plus 10, which will be positive 3, minus 3, which is going to be 0. And of course, if I substitute a number into a polynomial and I get 0, then that means that that number was a root. So we can now write, therefore, x equals 1 is a root of our cubic polynomial. And by the factor theorem, that means that x minus 1 is a factor. Right, so if you just want a recap of the factor theorem, right, the factor theorem states that if x equals a is a root, x minus a is a factor, and vice versa. So for example, if 3 is a root, x minus 3 is a factor. If 5 is a root, x minus 5 is a factor. If negative 2 is a root, x minus minus 2, so x plus 2 is a factor. And vice versa, right? If x minus 10 is a factor, x equals 10 is a root. Okay, so we now know one of the roots, and because we know the roots, we also know one of the factors. So if we know a factor, we can now do polynomial division to find other factors. So I'm going to take this cubic, 2x cubed minus 9x squared plus 10x minus 3, and I am going to divide this guy by x minus 1. Okay, so how do I do the polynomial division? Well, I take the first term, which we call the leading term, 2x cubed, and I divide it by x. And if I do that, I get 2x squared. Okay, and then I take that 2x squared and I multiply it by our divisor. I multiply it by x minus 1. So if I do that, I get 2x cubed minus 2x squared. Now what I do is I subtract that off, put the minus sign on the right. So 2x cubed minus 2x cubed is 0, cancels. Minus 9x squared minus 2x squared is minus 7x squared. So I get minus 7x squared. And the remaining terms remain the same because, I haven't subtracted anything from them. Okay, so this means that negative 7x squared is our new leading term. So I then divide this by x, which gives me negative 7x. I multiply negative 7x by my divisor here, and that gives me negative 7x squared plus 7x. And again, I subtract. Negative 7x squared minus 7x squared is 0. 10x minus 7x is 3x. And then I still got minus 3. Okay. And then lastly, 3x is my new leading term. I divide it by x. That gives me 3. And I multiply 3 by the divisor, which is 3x minus 3. And of course, that subtracts off to give 0, which is what I expect, because we know that x minus 1 is a factor, which means there's no remainder. So what have we just done? We have taken our cubic, right, which was 2x cubed minus 9x squared plus 10x minus 3. And we divided it by x minus 1. And that has given us a quadratic, which was 2x squared minus 7x plus 3. 2x squared minus 7x plus 3. Well, okay, if I multiply both sides by x minus 1, then on the left-hand side, I'm just left with the cubic. On the right-hand side, I've got that times by x minus 1, right? So in other words, what I've done is I've taken the cubic, basically, and I've now rewritten it in factorized form with the factor x minus 1 and this quadratic factor here, 2x squared minus 7x plus 3. And the question is, well, can I factorize that quadratic? Well, let's have a go, right? I'll have 2x and x, and got my x minus 1 over there. So what numbers would I need? Well, I need two numbers that multiply together to give positive 3, and those numbers have got to combine to give negative 7. So they're both going to be negative, aren't they? Because negative times negative is a positive. And I suspect if I make that minus 3 and that minus 1, that's going to work, right? Because negative 1 times negative 3 is positive 3. 2x times negative 3 is negative 6x, and then minus x gives me negative 7x. Okay, so that's the factorized polynomial. And remember, that's that's equal to 0, right? That was the initial thing. So we're trying to find the x-intercepts, right? And so therefore the x-intercepts will be x is equal to a half, because that's where 2x minus 1 is equal to 0, or x is equal to 3, that's where x minus 3 is equal to 0, or x is equal to 1, okay, where x minus 1 is equal to 0. So those are the three roots of that polynomial. Okay, then question 8, which is a logarithm question. We want to write down the set of values of x for which log base 5 12x minus 4 exists. Well, essentially, I mean, it's only 1 mark, right? But the argument of any logarithm of any base cannot be 0 or less than 0, right? It has to be a positive number. So by the argument, I mean this thing here, right? The number that goes inside the logarithm, that thing must be positive. So we can just straight away write that 12x minus 4 has to be greater than 0, right? So 12x must be greater than 4, which means that x must be greater than a third. Okay, so hopefully that's quite straightforward. Okay, part B, a little bit more complicated. We've got log base 5, 12x minus 4 is equal to 6 over log base x, 125, plus 1. We want to solve this. Now, the first thing you should really notice is that we have got logarithms with different bases, right? So we've got log base 5 and we've got log base x. And so we're going to have to use the change of base formula. Now, what is the change of base formula? Well, let's say I have got log base a of some value, call it big X, and I want to change it. So it's got a different base, so it's now log base b of big X. Then to do that, I've got to divide by log base b of a, right? So in other words, log of the new base of the old base, right? So if you want a way of remembering it, essentially on the right-hand side, the two bases of the logarithms must be same, right? This is base b, that's base b, okay? So in this particular case, let's say we take log base x 125, and we want to convert that so it's got base 5, right, like this logarithm. Then we're going to have log base 5 125, and we're going to divide it by log base 5 of the old base, which was x, okay? Now, we know that log base 5 125 is 3. Why is that? Well, because 125 is 5 to the power of 3, right? So we've got 5 to the power of 3 there. And what does the logarithm actually mean? Well, it basically means, right, what power do I have to give this base 5 in order to get this number here, 5 to the power of 3 or 125? Well, what power do I have to give 5 in order to get 5 cubed? Well, that power's got to be 3. So I can get rid of that and say, okay, this guy here is actually equal to 3. Now, at this point, we've really, to be honest, we've already done all the heavy lifting. We've just got to substitute into the equation. So we've got log base 5, 12x minus 4. So let's write that out. So log base 5, 12x minus 4 is equal to 6 over log base x 125. Okay, so we've got 6. And if I think of, what is 1 divided by log base x 125, well, then I've just got to kind of invert this guy here, right? So log base x 125 is this. So if I want 1 divided by that, I just flip this fraction here, which gives me log base 5x. So log base 5x over 3. And then lastly, we've got there plus 1. Okay, so I think we can simplify, right? So log base 5, 12x minus 4 is equal to 2 log base 5x plus 1. And I can use one of the log rules and say, this is a coefficient of 2 for my logarithm, but I can move that coefficient to 2 and I can bring it up here as a power, right? Now, if you've forgotten that, what's the log rule that I can use there? If I've got log of a to the power of p, I can write that as p times by log a, right? So I've used that rule. So I'm going to write now log base 5, 12x minus 4 is equal to log base 5 x squared plus 1. Okay, well, next thing I'm going to do is I'm going to rearrange, and I'm going to subtract the log x squared onto the left-hand side. So I've got log base 5, 12x minus 4 minus log base 5 x squared is equal to 1. So now I've got one log subtracted with another log of the same base. So I can use my another log rule, which is if I've got log a minus log b, that is equal to log of a divided by b, right? Where it must be the case that all the bases are the same, by the way. So I can rewrite this and say this is log base 5 of 12x minus 4 over x squared is equal to 1. Okay, all right then, so we only got a couple of steps left. I can now convert this into exponential form because I've got a base of 5 and a power of 1 must be equal to this. So I can rewrite this as 12x minus 4 over x squared is equal to 5 to the power of 1. Now, if you're not sure about that as well, that means you in a way you don't understand the key principle of a logarithm. A logarithm is just another way of writing an exponential. So for example, if I've got 2 to the power 3 is equal to 8, that is an exponential equation. How do I rewrite that as a log? Well, my base is 2. I get an end result of 8. And how do I do that? With a power of 3, right? So this logarithmic form is another way of writing this information here, which is in exponential form. And why do we do it? Well, because the logarithm puts the emphasis on the power, right? It tells us what the power is that took us from a base of 2 to 8, right? So that's what's going on there. All right, then. So last step, I'm going to multiply through by x squared. So 12x minus 4 is going to be equal to 5x squared. And so this is now just a quadratic, right? So, and though 0 is equal to 5x squared minus 12x plus 4. So I've basically just got to rewrite this quadratic. I've got to factorize this quadratic, do beg your pardon. So that'll be 5x, that will be x. Oh my goodness, 2 and 2 probably, minus 2 minus 2. If I do that, negative 2 times negative 2 is positive 4. 5x times negative 2 is negative 10x, minus 2x is minus 12x, so that works. And so therefore we end up getting the solutions. X is equal to 2/5, which is 0.4, or x is equal to 2. Now, I should just be very careful at this point because it may be the case that one of these isn't valid, right? Because if we remember at the start, part A, write down the set of values of x for which that logarithm exists. So all the x's need to be greater than a third. Well, let's just go down. Are both of those values greater than a third? Well, yes, right? Because that's 0.4, which is bigger than 0.33, and that's obviously bigger than a third as well, right? So both of those solutions are acceptable, but just be aware because you may be asked a situation where one of the solutions isn't acceptable, and you need to be careful about that. Okay, then question 9. Apologies that it's very small, but I've had to kind of zoom it so that we can fit it on the page. The point A with the x coordinate of 2 lies on the curve the square root of 4x plus 1, so that's this guy here. The diagram shows part of this curve and the tangent to the curve at A. All right, so that's the tangent to the curve at A. Find the area of the shaded region enclosed by the curve, the tangent and the x-axis. In other words, this whole thing here. Okay, now then, students, when they see this, they tend to say to themselves, oh, this is an integration question. That's kind of true, right? So it's not exactly wrong. But you want to think of it as a bigger picture thing first, right? You want to say to yourself, what I'm trying to do is I'm trying to find the area of that shaded region. So in order to do that, what is it that I need? What do I need to do that? Well, the first thing you can say to yourself is, well, that shaded region is kind of made up of two things. So the first of these things, I can imagine it, is like the area of this triangle here. Okay, so I got that triangle there, which is made by the x-axis, the tangent line, and this kind of vertical line here. And on the other hand, I've got kind of this area here. So I'm going to try to do that, and it's going to be a little bit messy, but it's kind of like that area there, right? Which is made up of the curve and then that area there, right? So this guy here is that little green region. And so if I want to find the area of the shaded region, then what I want to do is I want to find the area of the blue triangle and then subtract away from it the area of this green region. Okay, so let's now split that apart. If I want to find the area of the blue triangle, what would I need? The triangle is half of base times by the height. Okay, so the first thing I'm going to need, so I'm going to need to know the height of this, and I'm going to need to know the base of this. So that means I've got to find coordinates. Specifically, I need to know this y coordinate there, this x coordinate here, and this x coordinate here. Okay, well, we already know this x coordinate, that's 2. How could we find that y coordinate? Well, we can just substitute x is 2 into the curve, can't we? So if I say, when x is equal to 2, what's going to happen? Well, we're going to get y is equal to the square root of 4 times by 2, which is 8, plus 1, which is 9. So y is equal to 3. So the y coordinate of A is 3. right? So I can indicate that on as well. So that y-coordinate there is 3. And that means that the height of our blue triangle is 3. Okay then, so what else do I need? Well, I need to find this x-coordinate here. Well, what is that x-coordinate? That x-coordinate is the x-intercept of the tangent line. Okay then, so that means I need to find the equation of the tangent. How do I find the equation of the tangent? Well, I'm going to need to know the coordinate point that the tangent line goes through. Well, that's easy. It's the coordinate point 2, 3, because it goes through A. I need to know the gradient of the tangent. Well, how do I get the gradient of the tangent? I've got to differentiate the curve. So now I'm going to say to myself, okay, I've got y is equal to square root 4x plus 1, which is 4x plus 1 to the power of a half, right? And I will differentiate that using the chain rule. So the half comes to the front. I've got 4x plus 1 here to the power of negative a half. And I differentiate the 4x plus 1, I get 4. And I times through by 4. Right? So that's differentiating the curve. Now I want to find the gradient at the point A, right? Because I want to find the tangent at A. So I want to find the gradient when x is 2. So when x is equal to 2, I've got y prime is equal to, well, a half times by 4 is 2. Let's just get that out of the way. 4 times 2 is 8, plus 1 is 9. 9 to the power of negative half. Now, what does the power of negative a half mean? It means, well, the negative means 1 divided by, it's reciprocal, and the half means square root. So it's 1 over the square root of 9, and the square root of 9 is 3. So that is the gradient of the tangent. Okay, so now we've got the gradient of the tangent, and we know the point A that the tangent line goes through, so we can use the equation of the line y minus y1, which is 3, is equal to m, 2/3, x minus x1, which is 2. Right, so that is the equation of the tangent at A. And why did we find that equation again? Because we want to find the x-intercept, right? So we're going to find the x-intercept now. So when do we get an x-intercept? X-intercept is when y is equal to 0. So we got 0 minus 3 is equal to 2/3 of x minus 2. Okay, so I multiply everything through by 3, so I get negative 9. And I expand, multiply the 2, so 2x minus 4. So 2x, if I add 4 to both sides, is equal to negative 5. So x is equal to minus 5 upon 2. Right, so this x-coordinate now, that x-coordinate there is minus 5 upon 2. And why did I want that again? Well, because I want to find the length of this base of my triangle. So this is a length of 2, and this will be a length of 5 upon 2, right? So if I add those two together, that's 2 plus 2.5 is 4.5, or 9 upon 2, right? So the base is 9 upon 2. Okay then, so I can go over here and say, all right, well, the area of the blue triangle, area of the triangle, is equal to half of the base, which is 9 upon 2, times by the height, which is 3. And that's going to give us an area of 27 upon 4. Okay, so that's the area of our blue triangle. So we've done all of that. Okay, so the next thing we want to do is we want to find the area of this green region. Okay, so we want to find the area below this curve. So to find the area below the curve, we need to integrate the curve, but we need to integrate it between this point where we start and this point. Well, we know that that point is x is 2, but we don't know what this point here is, right? We don't know that. We just know it's the x-intercept. So we want to find the x-intercept of this curve. So the x-intercept is when y is equal to 0. So let's just go over here again. Woo. Let's go down. So x-intercept of the curve is when y is equal to 0. So we're trying to solve 0 is equal to the square root of 4x plus 1. So 0 is equal to 4x plus 1. So x is equal to negative a quarter. There we go, all done. So, so that x-coordinate there is negative a quarter. So if we want to find the area below the curve, so the area under sorry about the handwriting, guys, area under the curve, is going to be the integral between -1/4 and 2 of the square root of 4x plus 1, so 4x plus 1 to the power half dx. Okay then, so we're almost there. So we just now got to do the integration. Now notice, by the way, look how much work we've actually had to do before we even get to do integration, right? So, you know, what I said at the beginning is, you know, yeah, this is an integration question, but actually, to be honest, integration is like quite a tiny part in a way. All right, so let's integrate this. So firstly, I add 1 to this power. So I get 4x plus 1 to the power of 3 upon 2. I divide by the new power. So dividing by 3 upon 2 is the same as timesing by 2 upon 3. I then look at the coefficient of x. In this case is 4. And I divide through by 4. And this is all got bounds because it's a definite integral between -1/4 and 2. Okie dokie. Well, I think I can pull out the constant term, right? So I've got 2 over 12, which is the same thing as a sixth. So I'll just pull out the sixth. Okay, so I've got the sixth like that. And then what I've got to do is I've got to substitute in the top bound here, 2 into here, and I've got to substitute the lower bound, which is -1/4. So if I substitute in 2, I've got 4 times by 2 is 8, plus 1 is 9, so that's 9 to the power of 3 upon 2, minus, substituting the lower bound, so -1/4 times by 4 is -1, plus 1 is 0, right? And to the power of 3 upon 2 is still 0. So what do we got? We've got a sixth of 9 to the power of 3 upon 2. Well, what does the power of 3 upon 2 mean? Well, the denominator, the 2, means square root. So we've got square root 9. And the numerator, 3, is just a normal power. So it's the square root of 9 cubed. The square root of 9 is 3. And 3 cubed is 27. So we've got 27 upon 6. And we can then divide that by 3, which is going to be 9 upon 2, I believe. All right, so that's the area of the green region. So if we've got the area of the blue and we've got the area of the green, we can find the total area, I think. So area of the blue was 27 upon 4. The area of the green is 9 upon 2. So the shaded area is equal to the area of the blue, 27 upon 4, minus the area of the green, which was 9 upon 2. So it's 27 upon 4 minus 18 upon 4, give it the same denominator, which is 9 upon 4. There you go. Okay, so I know that's a long question, isn't it? But that is exactly why we do add maths, actually. We learn add maths principally so that we can develop the skill of working ourselves through our own initiative through a long and complex problem. Right, so if you're able to do that, my congratulations to you. That's really excellent. And I hope for those of you who weren't quite able to do that, you could see my method and my approach, right? And my approach is not, oh, let's integrate straight away. My approach is, okay, what's the big picture? What do I need? What are the pieces which I need to put together? Okay, I need to find this coordinate. I need to find that coordinate. I need them in order to find this area, or I need how am I going to find this coordinate? I need to find the tangent first. How do I find the tangent? I've got to differentiate. So really what's happening is, in order to answer the question, I am having to ask myself lots of questions, right? I have to say to myself, okay, I need to find this coordinate. I need to differentiate. Why is that? Well, because how do I find the area of this triangle? I get this coordinate. How do I get that coordinate? Oh, it's the x-intercept. How do I get the x-intercept? Oh, it's the tangent line. Okay, how do I get the tangent line? Oh, I need to differentiate. So you want to be in the habit of asking yourselves those questions. And the more that you can do that, I think the more you'll find, to your surprise, right, that you'll be able to do these questions a lot better. Okay, good luck. Okay, question 10. We've got trigonometric identity question here. So we want to show that this whole thing can be written as sec theta. And basically, you see you've got here cosec squared minus 1 and tan squared plus 1. The key to this is really identifying that these are going to be using the trigonometric identities which are given in the front of your exam paper. So if you just go to your list of formulas on the first or second page, what you should see is you should see a couple of things. You'll see sine squared theta plus cos squared theta is equal to 1. And next to that, you'll see sec squared theta is equal to 1 plus tan squared theta. And then cosec squared theta is equal to 1 plus cot squared theta. Okay, so if you can recognize that because you've got cosec squared and tan squared, you're probably going to be using these formulas, then I think your chance of doing this question is quite high, right? So let's say we've got the identity I. So what's that going to be? Well, we've got sine theta divided by the square root of cosec squared minus 1. Well, if I subtract 1, right, from both sides of this identity, so I get cosec squared minus 1, that's going to be equal to cot squared. Right, so this is the square root of cot squared theta. Next, what's this guy going to be? Well, I've got the square root of 1 plus tan squared. Well, 1 plus tan squared is sec squared. So this is sec squared theta. Okay then. Well, obviously, if I square root, then I'm going to get sine theta over cot theta. And if I square root here, I'm going to get sec theta. All right, so we're quite close now. Now, what is cot? Cot is the same thing as 1 divided by tan. So we've got sec, cosec, and cot. And the key to knowing each of those is to look at the third letter. So cot theta is 1 upon tan theta, because the third letter of cot is t. All right, so 1, 2, 3, t. So it's 1 divided by tan. So 1 divided by cot, right, is going to be equal to tan, right? Because cot is 1 divided by tan. So if I invert it, 1 divided by cot is tan. So I can say that here what we've got is we've got sine theta times by tan theta. And in the same way, right, what is sec theta? Sec, we look at the third letter, right? So 1, 2, 3. The third letter is C. So sec theta is 1 divided by cos theta. And therefore, 1 divided by sec is just equal to cos. So this guy is cos theta. Okay? All right then, so what have we got here? We have got sine theta times by tan theta. Well, sine is, tan is sine theta over cos theta. And so therefore, what I'm going to have is sine squared theta over cos theta plus cos theta. So we're getting closer. I've now got to combine these two expressions together. And how am I going to do that? Well, I've got to give them the same denominator. So imagine for a second, right, this is cos theta divided by 1. So how am I going to give it the same denominator? Well, I've got to multiply top and bottom by cos theta. Okay, so if I do that, then what we're going to get is we're going to get sine squared theta over cos theta plus cos squared theta over cos theta. And that is therefore sine squared plus cos squared, sine squared theta plus cos squared theta over cos theta. So I combine the two fractions. And then we know from our identity, right, if we go right up to the top again, sine squared plus cos squared is 1. So I can go down here and say, okay, sine squared plus cos squared, that's equal to 1. So we've got 1 divided by cos theta. And 1 divided by cos theta is the same thing as sec theta. Okay, so we have proven the identity, it took us quite a bit of work, that this whole thing can be written as sec theta. All right then, part B, given that sec x is equal to alpha, where x is between 3 pi by 2 and 2 pi, find sine x in terms of alpha. Well, we'll deal with this part just in a moment, okay? But let's just see if we can find an expression for sine in terms of the sec. Well, we've already noted that we've got the identity sine squared plus cos squared is equal to 1. So sine squared, beg your pardon, plus cos squared is equal to 1. And we've also noticed that sec is 1 divided by cos, right? So we did that in the previous one, right? So sec is 1 divided by cos. We look at the third letter, right? Third letter is c, so we know it's 1 divided by cos. So if sec is equal to alpha, then we can say that cos x must be equal to 1 divided by alpha, right? Because I just kind of invert the fraction. So if I then substitute this into the identity, I've got that sine squared x plus cos squared, which is 1 upon alpha squared, is equal to 1. And therefore, sine squared x is equal to 1 minus 1 upon alpha squared. And that means that sine x is equal to the square root of 1 minus 1 upon alpha squared. But there's a little trap here, which I'll just highlight, which is a lot of people will forget that, of course, it can be plus or minus the square root. And that's that plus or minus is going to help us to figure out what's going on here, or rather this range of values of x is going to help us to determine whether or not this is positive or whether it is negative. Now, in order to do that, we actually do need to understand what's happening with sine and cos and tan. Now, a lot of you know this as the quadrant method, but often you don't actually understand, what the quadrant method represents, what it means, and so therefore you get a bit confused. So I'm going to try to explain it so at least you have the concept a bit more clearly in your mind. So the quadrant method, or rather sine, cos, and tan actually, are coming from the unit circle. The unit circle is the circle which has got radius of 1, right? So it goes 1, 1, negative 1, negative 1. And I want you to imagine that on this circle, we've got a point, right? And that point has got an x-coordinate and a y-coordinate. And that point makes an angle with the positive x-axis, right? So this point here makes an angle of theta with the x-axis. Now, imagine that I take the point and I drag it all the way around the circle, right? So as I drag the point around the circle, the x and the y coordinate changes. Okay, so for example, when the angle is 0, in other words, when I'm here, the x coordinate is 1, the y coordinate is 0. But as I drag the point around to here and the angle is 90 degrees, the x coordinate is now 0 and the y coordinate is 1. And as I drag the point around to here and the angle is now 180 degrees, the x coordinate is negative 1 and the y coordinate is 0. What does that mean? It means that basically the x coordinate is a function of the angle. In other words, it depends upon what the angle is, right? So if I change the angle, I change the x coordinate. And the same thing's true with y, right? The y coordinate is also another function of the angle. If I change the angle, I change what the value of y is. Well, those two functions are what you call cos theta and sine theta. This is really the most important thing. What do we mean when we say cos theta? We mean the x-coordinate on the unit circle for that particular angle of theta. In other words, if I say, cos 10, what does cos 10 literally mean? It means what's the x-coordinate when the angle is 10? And the same thing for sine theta, right? Sine theta represents the y-coordinate. So if I say, what is sine 100? It means what is the y-coordinate when the angle is 100? Or if I say, what is sine 50? It means what is the y-coordinate when the angle is 50? Now, because this is the case, right, we should know when sine and cosine are positive and negative, right? Because when is cosine going to be positive? Well, it's going to be when the x-coordinate is positive. When is the x-coordinate positive? Well, it's everywhere on the right-hand side of the graph, right? So the x-coordinates are going to be positive here, and so cos is going to be positive here and here. Similarly, when is sine going to be positive? Well, it's going to be where the y-coordinate is positive, and the y-coordinate is positive in the top two quadrants. So sine is going to be positive here and here. And lastly, tan, right, which is sine divided by cos. How will tan be positive? Well, either sine and cos are both positive, in which case positive divided by positive is positive, right? So that would be positive there. Or sine and cos are both negative, in which case negative divided by negative is a positive, right? So sine is negative here, cos is negative here, so tan will be positive here. Right, so do you understand that? So basically we know that all functions are positive in the first quadrant, sine in the second, tan in the third, and cos in the fourth. Now, we are told in the question that our angle is between 3 pi by 2 and 2 pi. In other words, we're in the fourth quadrant. We're here. Okay, and so if we're here, then the value of the cosine should be positive, all right, because cos is positive in this quadrant, and the value of the sine should be negative, right, because sine is negative in this quadrant, right, because the y value is going to be negative. So when we look at this, right, is this going to be the positive or the negative? Well, it's got to be the negative. So the final solution is going to be that sine x is equal to negative the square root of 1 minus 1 upon alpha squared. Okay, and I'm just going to very briefly just check the mark scheme, see if that's all okay and whether or not there's anything else they've asked to add, but I don't think there will be. So let me have a quick look. No, that's exactly right. So the final mark for that is indicating that you have got the negative there. Okay, but the most important thing is actually you understand where that negative has come from, and I think really to understand that you actually need to have a very firm grasp that cosine and sine represent the x and the y coordinates on this circle, right? If you can understand that, a lot of these problems will become a lot easier. Okay, then question 11, which is an arithmetic progression question. We've got an arithmetic progression that's got a common difference of d. The third term of this progression is 10. Write down expressions for the first term and the second term. Give your answers in terms of d only. Well, I think it should be fairly straightforward. Imagine we've got a progression, right? We've got a first term, we've got a second term, we've got a third term, got a fourth term, and so on and so forth. And we're told that the third term is 10. And in an arithmetic progression, right, we're always adding the common difference, right? So if I want to go from any term to the next term, what have I got to do is I've got to add d, right? So the next term here would be 10 plus d. But similarly, right, if I was to go the other way, then I'd have to subtract d. So this would be 10 minus d, and this would be 10 minus 2d, right? Because the whole principle of the arithmetic progression is to get to the next term, I'm always adding that common difference d, right? So I think that should be fairly straightforward. Next, part B, when each of the first three terms is squared, the sum of these squares is 140. There are two possible values for d. And using your answer for part A, find the sum of the first 200 terms of the progression with the smaller value of d. Okay, so when each of the first three terms is squared, the sum of these squares is 140. In other words, if I take this and I square it, and this and I square it, and this and I square it, and add all those things up, I should get 140. So let's just write that down. 10 minus 2d all squared plus 10 minus d all squared plus 10 squared is equal to 140. All right, so let's expand that. So expand the bracket, that'll be 100. So you get minus 20d doubled is minus 40d plus 4d squared plus 100 minus 10d doubled, so minus 20d plus d squared plus 100 is equal to 140. Okay, and let's try to combine it. So I've got 4d squared plus d squared is 5d squared. Minus 40d minus 20d is minus 60d. And then what else have I got? I've got the 100 plus 100, which is 200, plus another 100 is 300. And I subtract the 140, which will give me 160. And that's a quadratic, and I would be well advised to divide everything through by 5. So d squared minus 12d and plus 32. Now, if you want a quick way to divide by 5, because you don't have a calculator, dividing by 5 is the same thing as dividing by 10 and then timesing by 2, right? Or timesing by 2, dividing by 10, same thing. So if I got 60 divided by 10 gives me 6, double it gives me 12. 160 divided by 10 is 16, double it, I get 32, right? So that's how I do it. And I want to factorize this, so I've got d, and I want two numbers to multiply together to give 32. It's going to combine to give negative 12, so I think that's going to be negative 8 and negative 4 by the looks of it. And so I've got two solutions. I've got d is equal to 4 and d is equal to 8. So those are two options. All right, now let's just go to read the rest of the question. So using your answer to part A, find the sum of the first 200 terms of the progression with the smaller value of d. All right, so the smaller value of d is 4. So we're going to use 4. Let's just go back to our progression. Oh, okay, well, now we know, don't we, that a third term was 10. If I subtract 4, I get 6. If I subtract another 4, I get 2. Okay, and if I add 4, I get 14 there. So the first term of my progression is 2, and the common difference is 4. And I want to find the sum of the first 200 terms. So let's just write out the formula. The sum of the first n terms is n upon 2, 2a plus n minus 1d. And so then if I just substitute in, right, so I'm now trying to find the sum of the first 200 terms. This is going to be 200 divided by 2. 2 times by a, which I think was 2, wasn't it? So 2 times by 2 is 4, plus n minus 1. So 200 minus 1 is 199, and d is 4. Well, I mean, 200 divided by 2 is 100, and I've got 199 lots of 4, plus another lot of 4. So I'd be crazy to multiply it out and then add 4, right? I've got to realize this is 200 lots of 4, and 200 lots of 4 is 800. So I've got 100 times by 800, and that's going to be 80,000. Okay, so the sum of the first 200 terms there is 80,000. Okay, then question 12, the last question on the paper. In this question, n is greater than or equal to 6. Use an algebraic method to show that nc5 minus n minus 1c5 can be written as n minus 1c4. Now, I think it's good to know what NCR is, right? And that's the formula which I think is given to you in the front of your formula book. Let me just double check that. Yes, it is. Okay. So in the formula book, it's written in the column notation NR like that. And it's equal to n factorial over r factorial n minus r factorial. Okay. Now then, so we want to show that this thing, NC5 minus this thing, can be written as that. So let's just write that out. What's NC5? NC5 will be n factorial over 5 factorial times by n minus 5 factorial. And what's n minus 1C5? Well, that, again, using the formula, will be n minus 1 factorial over 5 factorial n minus 1 minus 5 factorial. And I think it's probably going to be a helpful thing just to know what we're aiming for, right? What's going to be n minus 1 C4, right? Well, n minus 1 C4 is going to be n minus 1 factorial over 4 factorial times by n minus 1 minus 4 factorial. So in other words, n minus 5 factorial. So the end result of doing this should be to get that. So that's where we're aiming for. Now, in order to do this, there is essentially a big trick, which I think you need to know. Otherwise, it's going to be very, very hard to do this. So I'm just going to move across, I think, to the left. Trick is this. Let's say we've got 5 factorial. What does that mean? It means 5 times 4 times 3 times 2 times 1. Well, if I was to split the 5 off from the 4 times 3 times 2 times 1, I can rewrite this as 5 times by 4 factorial, right? That's the same thing. And in a similar way, if I had like 10 factorial, that would be equal to 10, beg your pardon, times by 9 factorial, right? Because it's 10 times by 9 factorial, which is 9 times 8 times 7 times 6. Well, if we just extend this idea to like n factorial, right? So we've got n factorial. What does that mean? It means n times by n minus 1, right? Because I keep subtracting 1 to get to the next number, times by n minus 2, times by n minus 3, times by n minus 4, so on and so on and so on, until we get 3, 2, 1. Okay? And that means that actually we could rewrite that as n times by n minus 1 factorial, right? Because it's the same principle as what we've done above, right? Because here what I've done is I've split off the n minus 1, n minus 2, n minus 2, da, 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 da. All that there is n minus 1 factorial. I've split it off from the n. Okay, so let's now go over to here and let's see what we can do. So I think, I mean, there are a couple of things I could do, but I'm going to take that n and I'm going to split it up and write it as n times by n minus 1 factorial. So I've got n times by n minus 1 factorial over 5 factorial times by n minus 5 factorial and minus n minus 1 factorial over 5 factorial, and I've got n minus 1 minus 5, right, which is n minus 6 factorial. So I've got n minus 6 factorial. Okay, now I think probably at this stage it's worth remarking that there are things that we can factorize out, right, so that we don't have such a complicated thing to write each time. So I can straight away factorize out n minus 1 factorial, and I can also factorize out 5 factorial, I think. So that's what I'm going to do. So I'm going to write down, we got n minus 1 factorial over 5 factorial. So we factorize that out, bracket. What do we got left? N over n minus 5 factorial minus 1 over n minus 6 factorial. Okay, so if you think about it, what have I done? I've factorized out from this term the n minus 1 factorial and the 5 factorial. Okay. Well, I think I can probably use my trick again, right? Because what's n minus 5 factorial? It means n minus 5 times by n minus 6 times by n minus 7 times by n minus 8. In other words, I can rewrite it. And I'm going to rewrite it. Just give me 1 second. I'm going to rewrite it like this, as n minus 5 times by n minus 6 factorial. Okay? Minus 1 over n minus 6 factorial. Okay, so I've split it up. And so then I've got these two terms here, right? And what would be really great is if I can combine them. Well, if I want to combine them, I need to give them the same denominator. And so I need to take this fraction here and multiply top and bottom by n minus 5. So if I do that, I get n minus 1 factorial over 5 factorial times by big bracket n over n minus 5 n minus 6 factorial minus n minus 5, I'll put it in brackets so I don't forget the negative, n minus 5 times by n minus 6 factorial. So now I can combine those two fractions, right? So I get n minus 1 factorial over 5 factorial. And on the top, what have I got? Well, I got n minus n, so it cancels, minus 5, which is 5, over n minus 5 times by n minus 6 factorial. All right then. Now, here we've got to think about where we're heading. Where are we heading? We said we wanted to get this thing, right? We've got n minus 1 factorial, 4 factorial on the bottom, and n minus 5 factorial on the bottom too. So what do we got? We've got n minus 1 factorial on the top, so that's good. We want a 4 factorial on the bottom, and we want an n minus 5 factorial on the bottom. So how are we going to manage that? Well, let's use our trick again. I am going to rewrite the 5 factorial as 5 times by 4 factorial. And then this will be 5 over n minus 5 times by n minus 6 factorial. So the 5's cancel, gone and gone. And so now I've got my 4 factorial, right? So this term here is correct, and this term here is correct. Now, I just want, in the end, to have n minus 5 factorial. Well, hang on a minute. If I've got n minus 5, and I times it by n minus 6 factorial, that's actually n minus 5 factorial, right? This whole thing here is n minus 5 factorial. And that's a bit hard to see, but it is essentially this trick in reverse. So this trick in reverse, right? If I took n factorial, I could split it to be n times n minus 1 factorial. But in reverse, if I had n times n minus 1 factorial, I could go back to being n factorial. Right, now, if you're really not sure about that, let me just write it out for you kind of in full. Right, so we've got n minus 1 factorial over 4 factorial. And then what do we got here? Well, we've got n minus 5. And then what's n minus 6 factorial? Well, it means n minus 6 times n minus 7 times n minus 8 times dot, 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 times 3 times 2 times 1. Well, guys, what is this whole thing equal to? What is this whole thing? This whole thing is n minus 5 factorial. So I can then say, all right, this guy is now n minus 1 factorial over 4 factorial times by n minus 5 factorial. And if we really want to be just extra super duper clear, right, this is n minus 1 factorial over 4 factorial n minus 1 minus 4 factorial, which is the same thing as n minus 1 C4. Okay, so I'm absolutely, to be honest, I'm completely flabbergasted that that is only worth 4 marks. To me, that is completely insane, right? That should be worth 6 or 7 in my view, but never mind. I'm guessing they have to make the marks add up to 80. But I think really the key to it is just you're applying that trick again and again and again and again. And I think the way, a really helpful thing is just to have an eye on what your end goal is, right? So at the very beginning, I write out, this is the thing that I want, right? And that helps me because in the end, when I've got like this term here and this term here, I know, oh, okay, that's fine, right? That's already done. I don't have to do anything more. It's only the last term that I've got to kind of manipulate and see if I can change. So I think if you have a clear idea of your goal, your chances of doing it are better. Okay. All right. That's the end of this first paper, guys. I hope you're finding these helpful. If you are, please do like and subscribe to the channel. And you can comment below if there's anything that you're not sure about or you think would be more helpful in the future. I try to reply if I can. And please share it with your friends. I want more and more people to be able to benefit from these videos. And yeah, good luck with your studies.